Now we discuss the principle of machine. Principle of machine. Of machine. What is the principle of machine? Previous class we discussed basic terms of technical term. What is machine? Definition of machine. Uh, Define a simple machine also. Okay. Terms, some function and uses of simple machine. Okay. So here we discuss a simple principle of machine. Okay. So what is the principle of machine? The principle of machine, first we know the effort point and load point. There are two terms. First we know that. The two term is effort point. Understanding principle. First we know that two terms, effort point and another point is load point. Load point and effort point. So what is effort point? The effort point means the point at which the energy is supplied to the machine. Point at which energy is supplied. Energy is supplied to a machine. To a machine by the applying effort. By the effort. And what is the load point? A point where energy obtained to overcome the load. The point where energy is obtained by overcome is obtained by overcoming the load. Okay, so very important point, and these 2 points. And here is the important point. We know that the energy term. In previous chapter, we know that energy and what is the relation between work and energy. We know that because we know that the change in change in energy also equal to work done. It's energy gain also equal to change in energy also gain. So that is also equal to work done. It's energy loss, that is also equal to work done. And previously we discussed work input and work output previous talk. And here is a people efficiency also, that technical term here. Okay. So know that work input and work output, that is the work input and work output that related to energy. Okay, to energy. If input energy that is equal to input energy, that is work done also. Okay, input energy here is we know that that is related to work effort. So work effort means effort is a force, so effort force times displacement, and there is a displacement, so displacement is a displacement in effort term. Okay. So displacement means effort term. What is the effort term? That's the point of application. Displacement at the point of application of effort. Okay. So here is the effort point. So displacement of the point of displacement short form. Okay. Point of application. Point of application. And what is the output energy? Output energy. That is a load. Previous discussed the work output here. Here is the work output is also associated to workload, work on load. So here the load is a force time displacement. So here displacement, that is a point of application. Here is effort at the point of application. Okay, of load. In case of ideal machine means 100% efficiency means there is a work output is also equal to work input. There is a no loss. In terms of ideal machine, in ideal machine, ideal case, the output energy, sorry, that is output. Okay, that's not output. Okay, let's keep on output energy is also equal to input energy, input equal to input energy. So here, if output energy is equal to input energy, that means a 100% efficient, means no loss. So no loss, eta 100% percent. Okay. Now, if so, mechanical advantage. This also load or by effort. That's also equal. So that is one. And some consider, let's say that is load equal to effort, that is mechanical advantage also one, let's say. And velocity ratio is a displacement of effort by displacement of load is, and here we discuss the velocity ratio of the previous class. So this is effort by displacement of load. We get also that is also equal to 1. So MA, that is equal to VR. That's the important point. In ideal machine, MA is also equal to VR. Okay, but in that is ideal. But another important, there is a practical machine or an actual machine. There is a practical machine or actual machine. So a practical machine, that is a not a efficiency always not 100%. Okay, there is a loss. There is a no loss, but there is a loss. Is loss present. Loss present here. If a loss present here, so obviously that eta is not 100%, is obviously less than 100% loss, and there is a work input is always greater than work output. There is a loss. There are many reasons to loss. Okay, there is a work input is obviously work output is so obviously less than. So that's the important point. In there's a loss of a machine, loss of energy machine due to the mainly three reason here. Okay, that's main important. That is the main three reason. Obviously here important point. What is the MA and PA? If there is an error here, if MA load over effort, first is a load over effort, but if a load over effort mechanical advantage is a effort is in terms of related to that work input point, there is a load, but in terms of VR, that is also equal to displacement of dE by dL, and we know if I work is also related to these two terms. Obviously if a load effort is more and load is less, if less effort is more, so displacement of effort, obviously if I displacement effort is obviously more, that is obviously less. If denominator here, check, denominator is more. If denominator is more and here the numerator is more, so numerator is more means obviously consider that is a less than 1. If your numerator is more, we must say VR is greater than 1. So here we check that the MA, that mechanical advantage, obviously less than velocity ratio in that case. Okay, and here we discuss why there is a loss. There is a loss means suppose due to air, okay, and due to friction, okay, and due to the technical error, okay, a defect in present in machine defect, technical defect, not actual measurement. There is a huge number of error present. Actually, there is a error present. That is a defect. When you manufacture the machine, there is a defect present. There is a loss. Clear? Now the relationship between mechanical advantage, velocity ratio, and eta. That's important. Relation between uh, the mechanical advantage, velocity ratio, and eta. That's very important point in board exam. Derive the expression for relation between MA, VR, and eta. Very easy. And obviously we discuss in terms of efficiency. That is, we know that work output by work input, very easy. So work output means uh, output, there is a load related to output, load time displacement of load, and there is effort, that is a displacement of effort. So load by effort, we know that is a mechanical advantage. Okay, but displacement of load by displacement of effort, that is a reciprocal of velocity ratio. So here we get eta times VR, that is equal to mechanical advantage. We cross multiply these two, that is easy. Eta times VR, that is equal to mechanical advantage. Okay, there is an actual machine. We know that there is velocity ratio less, basically greater than mechanical advantage. Okay, obviously eta is less than 100% is very easy. Okay. Now we discuss a very simple machine is lever. Okay, lever. Okay. So what is a lever? Lever is a simple machine. Lever is a simple machine, or example of a simple machine. The rigid and a state bar. Okay, you know that class 6, 7, 8. Maximum you know that terms here. That is a lever. What is lever? Kind of 1 lever, kind 2 lever, kind 3 lever. Just recall this portion and some minimum number added here. Not concept added here. So yeah, because there's a velocity ratio, don't added this post class 10. Maybe they are not present in class 8 or 7. Okay, so principle of lever, there is a theta kind of lever, kind 1 lever, kind 1, kind 2, and there is a kind 3 kind of lever. Okay, if kind of 1 lever, there is a lever means a bar, there is a fulcrum point or junction point. Another point, end point is a load point. Another point is called effort point, and that is a load arm, and that is effort arm. Okay, that's a type 1 lever. If type 1 lever, the important point is fulcrum point or a junction point always in between load and effort. Either effort here or load here, or load here, effort here, or load these. That's not important. The important point is effort is fulcrum point is always in between load and effort. That is class 1 lever. And class 2 lever, if there is a bar, okay, and there is a fulcrum point is one side, either left side or right side, but always play in one side. Load in between middle, load in between fulcrum point, junction point or fulcrum point, and effort. So that is a load arm and that is the effort arm. We know that from first chapter what is load arm and what is effort arm. So an effort arm is effort, applied effort, when which point to apply the effort point, and fulcrum point, the displacement of these two is a effort arm. And kind 3, a class 3 lever, that is a bar, and here fulcrum point in one side, either left side or right side, there is a fulcrum point, and there is a effort and there is a load, and that term is called effort arm, that term is a load arm. That is effort in between load and fulcrum point. That is a kind 3 or class 3 lever. Okay, so very easy. Class 1 lever, the characteristics of class 1 lever, you know that class 1 lever means you know that mechanical advantage. uh, uh, Sorry, in case of class 1 lever, this mechanical advantage basis. First we know relation between make a concept, a principle of moment. You know that, okay. Mm, Load into load arm, that is effort into effort arm. So load by effort, that is equal to effort arm by load arm. So load by effort, you know that is a mechanical advantage. The mechanical advantage also the effort arm by load arm. Another point here. So mechanical advantage definition, another definition of mechanical advantage is advantage, the ratio of effort arm to load arm. Okay. Uh, There's a length. There is a length. That is also a mechanical advantage. Now in class 1 or kind 1 lever, class 1 lever, that is a diagram 1 means class 1 lever. We know that there is a chance is load arm is equal to effort arm. So mechanical advantage is 1. Okay. And another chance also that load arm is also greater than effort arm. There is a chance. So mechanical advantage here, if load arm is more, effort arm is less, there is a chance. So mechanical advantage all less than 1, not always less, but in that case less than 1. And if load arm is greater than effort arm, sorry, now is load arm is less than effort arm, is less than effort arm, load arm is less than effort arm. So we all get mechanical advantage is load arm is less, effort arm is more. Mechanical advantage always another greater than 1, not always greater than 1. There's a chance to greater than, in that case greater than 1. A 3 case is possible. Okay. So class 1 lever is mechanical advantage and velocity ratio of any value. Mechanical advantage is always 1, less than 1 or greater than 1. So velocity ratio being same, we know that velocity ratio No, simple, because you know that eta times VR, that is equal to AMA. We know that if AMA is any value, so obviously that VR also any value, either 1 or greater than 1 or less than 1. Efficiency, all the three values are efficiency here, equal to 1, less than 1, or greater. All three values are obviously possible, because there is three chances possible in diagram 1. That's why that three possible result is equal to 1, less than 1, and greater than 1. If velocity ratio are the same, eta also the same. Example of class 1 lever. Example of class 1 lever. A very easy example, like a seesaw. Okay, there is a example of seesaw, uh, like this, a seesaw. Some child stand here, someone stand here. There is a fulcrum point, and that is if someone is load, that is a effort. That is a seesaw. Okay, crowbar. Also the example of the class 1 lever. If basic one class 1 lever is fulcrum point always in between the load and effort. That is important. If any machine look like this, that's a class 1 lever. Okay. No matter how the mechanical advantage and velocity relation is greater than less than 1. Okay. So here important point is the fulcrum point in between load and effort. Okay. Now the class 2 lever. Class 2 lever. Yeah, class 2 lever, very important point. In case of class 2, see the diagram. Load in between fulcrum and effort. In class 2, there is a bar, there is a bar, that is a load, there is a effort, that is a fulcrum point. Okay. So here, load arm, that is a effort arm always greater than load arm. That is a always. That is always. Load arm is always less than effort arm. So class 2 or kind 2 lever. So mechanical advantage means effort arm by load arm. See that effort arm by load arm. So here effort arm by load arm. So effort arm is more, always greater than 1. So that is ratio always greater than 1. Okay. So here we check that MA is always greater than 1. So, okay. So, similar the velocity ratio VR is also more than 1. Okay. VR is also more than 1. If mechanical advantage is more than 1, velocity ratio always more than greater than 1. Because the velocity ratio, you know, that is equal to first we discuss what is the velocity ratio, d by dl. I think effort, displacement of effort by displacement of the load. So displacement of the effort, displacement of the effort by displacement of the load. Basically, displacement of the effort is the effort arm. The effort arm, that is a load arm. So that means velocity ratio is, these are the effort arm is a dE is more to dl. So dE is more to dl. So numerator is greater than denominator, always that means a greater than 1. So velocity ratio always a greater than 1, and MA also a greater than 1. Okay, that's a class 2 lever. So example is a bottle opener is a class 2 lever. Okay, is a nut cracker. Suppose an example is a nut cracker. What is a nut cracker? There is a nut, and here is another fulcrum point here. Uh, some finger fulcrum point, that is a load, that is a effort, that is a example of class 2 lever. Okay, now third, class 3 lever or kind 3 lever. Uh, Class 3 or kind 3 lever. So what is the class 3 and kind 3 lever? Very easy. So here that is a fulcrum point. You know that here is the effort, is the load. Uh, so very simple concept in class 3 lever, that is a effort arm, that is a load arm. So mechanical advantage we know that is equal to effort arm by load arm. Effort arm by load arm. So effort arm is always less than load arm. Effort arm is always less than load arm. Here the effort is always greater than load arm in class 2. In class 3, effort arm is always less than load arm. So mechanical effort arm is less. Numerator is less than numerator. Means always a less than 1 mechanical advantage. Okay, numerator is more, numerator is less. So mechanical advantage is less than 1. Similarly, the velocity ratio, we are similar like this. So basically less than 1 consider. Why? Because that uh, displacement of effort by displacement of the load. Uh, less than. The displacement of effort means a effort arm, that is also effort arm, displacement of the load, that is also represent that load arm, that is less than 1. So in that case, class 3, velocity ratio and mechanical advantage both are less than 1. So there is a class 3 lever. Take an example of class 3 lever as a, I think, a very example of sugar tongs. Sugar tongs is a very good example of class 3 lever. Like this. If in sweet shop we check, there is an sweet. Okay. Some that is a fulcrum point here. Okay, and that is a load, and someone applying effort here. Some hand uh, push this and grab this like this. Okay, this is also a example of class 3 lever, sugar tongs. So today I end the class here. We'll discuss the basic machine is a lever. Okay, next class we solve some numerical or any doubt in that lecture, previous lecture. Always put in comment section. I will try to give the answer. Okay, thank you.